With Kroger brand products from Baker's, you can make all your favorite things this holiday season. Because Kroger brand's proven quality products come at exceptionally low prices. And with a money-back quality guarantee, every dish is sure to be a favorite.
These are a few of my favorite things.
Whether you shop delivery, pickup, or in-store, Kroger brand has all your favorite things. Baker's, fresh for everyone.
Today's show is brought to you by ExpressVPN. Protect your online activity today and find out how you can get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Visit tryexpressvpn.com/space to learn more.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello again, and thank you for joining us on Space Nuts, the astronomy podcast. I'm your host, Andrew Dunkley, and astronomer at large, Professor Fred Watson, joins us yet again. Hello, Fred.
Hello, Andrew. How are you today?
I am sterlingly well. How are you?
Yes, I'm dollily well. There you go. Work that one out.
I wonder how many people will get that.
I don't even get it myself.
Yeah, I knew where you were coming from, which is a bit of a concern.
Yes, it is, isn't it? Never mind.
I'm not going to explain it. Someone's going to have to figure it out for themselves.
Yes.
Today, good grief, we're going to talk about exoplanets. There's a couple of stories in the news about exoplanets. One in particular is this discovery by ESO about an exoplanet that looks pretty hot, pretty darn hot. And has got quite a storm going on as well. So we're going to talk about that. And the number of exoplanets has surpassed a significant number. So we'll talk about that too. You may have heard that NASA's all-female spacewalk has been cancelled, which must be a great disappointment because it was going to be a huge milestone in space. I'm sure they'll get another chance, but it's not going to happen this time. And some questions, we were really whittling them down, Fred, but since we last spoke, we've received about 4 or 5, so we're back in debt. But we've got a couple. One about what happens when black holes die. What do they turn into, if anything? It's a good question. But I particularly love this one from Kevin in Melbourne about throwing stuff at Earth while you're in space. I mean, quite literally, you're outside and you throw something. What happens to you and to it? So it's a really interesting question. I've got a little anecdote to add because I actually saw a program recently where that situation actually arose. So it's a bit gruesome, but I'm going to tell it anyway. But first of all, Fred, let's start with this amazing story about this discovery in the form of an exoplanet.
Yeah, so this is some work that has been done on the European Southern Observatory's telescopes. The European Southern Observatory, of course, important in our deliberations because Australia is now involved with a strategic partnership with ESO, which allows our astronomers here in Australia access to their 4 giant telescopes, 8.2-meter telescopes down in Chile. However, those 4 telescopes are normally used independently, but you can link them together. And you can link them then with 4 smaller telescopes, which are called auxiliary telescopes. I can't remember, they're about 1.8 meters in diameter, I think, rather than the 8.1. And they're all hooked together with underground light paths that allow the beams from all these 4 telescopes to be combined. And what that forms is something called an interferometer. And an interferometer allows you to see things in very, very great detail. It's what the radio astronomers use all the time. They use arrays of telescopes to mimic a bigger dish and to beat down the amount of detail, or to beat up the amount of detail you can see, to beat down the resolution limit is the way I was about to say it, which is all about detail. Optical astronomy, visible light astronomy is a bit harder because you've got to combine the beams directly. So the technology has improved enormously in the last few years, and we've had some very spectacular results from this VLTI, as it's called, the Very Large Telescope Interferometer. We've seen the details of stars orbiting the black hole in the center of our galaxy, for example. But this latest research concentrates on extrasolar planets, the planets orbiting around other stars, and one in particular, which has been studied with the VLTI, a star that rejoices in the name of HR 8799e. The E tells you it's one of a number of planets orbiting the star HR 8799. The letter at the end tells you which order of planet it is in terms of discovery.
So hang on, it's the fourth planet because
that's right.
The star is actually the A.
Yeah. Sorry. It's the fifth. It's the fifth planet, because the star is the unadorned number.
Right.
So the first one is A, B, C, D, E. That's right. So it's the fifth.
This is quite a system, isn't it?
Yeah, it is. It is. And this is perhaps one of the most interesting of all the planets. First of all, this star, HR 8799, is a young star. It's only, 30 million years old, which is the blink of an eye in cosmic time, compared with the age of the Sun and the Earth, which is 4.6 billion years. So this is much, much younger. And that means it's a world that is still very, very hot from its formation. And in fact, the scientists estimate a surface temperature of 1,000 degrees Celsius.
Oh, boy.
Yeah. It makes our summers look quite benign, really, here in Australia. And the reasons for that are partly the still leftover energy within the body of the planet from its formation. But there's also a really strong greenhouse effect. That's the same thing that keeps the planet Venus warm. It's got a very strong greenhouse effect that holds its temperature at about 450, 460 Celsius.
And just to keep our American listeners, all three of them, happy, that's 1,832 degrees Fahrenheit.
Oh, there you go. Don't forget the 32 degrees.
No.
Yep. So, but the interferometry technique has basically now allowed people to look at the details of it. In particular, you get, because you can isolate the light of the planet only and nothing else, you can produce a spectrum of the planet's atmosphere. And it's very, very detailed, and that's what this work is based on. So basically the lead scientist is a man called Sylvestre Lacour, who's at l'Observatoire de Paris in France, and he has worked with colleagues in Europe. What Sylvestre says is our analysis shows that HR 8799e has an atmosphere containing far more carbon monoxide than methane, and something which is not expected from equilibrium chemistry. You'd expect those two basically not to exist together. And so he says we can best explain this surprising result with high vertical winds within the atmosphere, preventing the carbon monoxide from reacting with hydrogen to form methane. So there's clearly something really weird going on, and they infer that means very, very stormy weather. And they found that there are clouds, wait for this, clouds of iron and silicate dust in the atmosphere. And so when you put that into the picture with the carbon monoxide, the outcome is that the atmosphere of this poor little world is just one big violent storm. It's just a raging inferno of a storm.
It's got cancer written all over it.
It's got, yes, that's right. It's not good news.
No.
However,
the clouds of silicate and iron particles I can relate to with our dust storms out here.
Yeah, that's right, exactly. He said, this is Sylvester again. He goes on to say, our observations suggest a ball of gas illuminated from the interior, with rays of warm light swirling through stormy patches of dark clouds. Convection moves around the clouds of silicate and iron particles, which disaggregate and rain down into the interior. It paints a picture of a dynamic atmosphere. You can say that again. A dynamic atmosphere of a giant exoplanet at birth, undergoing complex physical and chemical processes. So what we're seeing here is, a phase that we know the Earth went through some pretty dramatic phases, but not as dramatic as this, because the Earth is a much smaller world than this one. This is bigger than Jupiter. It's a super Jupiter.
Wow.
So
it's a gas giant.
It's a gas giant.
Yeah.
Well,
but it might not be.
Yes, it's probably a gas giant. That's right, with all this stuff going on in the atmosphere. So if anybody a travel agent or anybody offers you a holiday on HR 8799E, I'd pass it over.
Yes, indeed. Wow. What a horrible place by the sound of it.
It sounds like a real dump, doesn't it?
We've got a few of them in our solar system, so not as bad as that. But
no, ours are pretty benign compared with this.
Yeah, but they're still horribly dangerous. If you've
Indeed.
ever got the chance to go there.
Yeah.
And we've been to all of them now, haven't we? One way or another?
Not in great detail. Uranus and Neptune are the ones in which we have the least amount of detail. Yeah. The others have all had a pretty good look.
Yes.
But returning to exoplanets, we have other news
yes,
as well.
This is quite astounding. I knew we'd found a lot, but there are a lot of them.
A lot, yes. So just about 4,000. When was the first one discovered? 1995. So we're talking about 24 years of activity, and I guess the outcome of all this is just that, as astrophysicists say now, pretty well every star in our galaxy will have at least one planet around it, and that was something that we guessed at years and years ago, but didn't have the wherewithal to measure it. So there are two big archives of these exoplanets that sort of bring together all the information that we have. NASA runs one. It's called the Exoplanet Archive, and they have, I think they're short, there's something like 3,926, I think, is the number that they've got. So they're just under the 4,000 limit, but they've got over 400 candidates which have already been detected by the TESS Space Telescope, just waiting for confirmation, and more than 2,500 nearly, that are still waiting for confirmation from the Kepler Space Telescope, of course, which is where most of this 4,000 came from. So if all of those turned out to be real planets, we're talking about something like, where are we? 3,000, 7,000, more like 7,000 altogether, yeah. Just turning to the other big...
I always forget to carry the one.
Yes. Just turning to the other big, I won't comment on that. The other big exoplanet list is a catalogue run by l'Observatoire de Paris, which we mentioned a few minutes ago. A lovely place, if ever you get the chance to go. Beautiful old building built in the 1670, I think it was built in. They've passed 4,000 already, and it's because they just have slightly different, categories of what these planets, whether they're confirmed or not. So the bottom line is 4,000 is about the number of exoplanets that we know, which means I'm going to have to update the chapter of the book that I'm working on at the moment.
So that's why I write science fiction, because you don't have to change anything.
Yeah, you have. There's several things. This book's all about cutting-edge science, and I tell you, it's a nightmare. Every time I finish a chapter...
The trouble with cutting-edge science is it's always in flux. So
it's in flux, yeah, exactly.
You'll publish the book and it'll be out of date next week.
It's out of date almost before it appears on the shelves, that's right. Never mind. It's not, the bottom line. Why do I write these books? To entertain people. That's really the only answer.
I should try.
Yeah, a milestone.
Yes.
A milestone.
Okay, so great news on exoplanets. You're listening to Space Nuts with Andrew Dunkley and Fred Watson. Now, let's take a little break and find out more about our sponsor, ExpressVPN, rated #1 by TechRadar. This is the one I use. I've been using it for a couple of years and I love it. When I joined ExpressVPN, they were brand new, new to the market, but I read a lot of reviews and did a lot of comparisons. And there was just something about their business model that I particularly liked. And a couple of years down the track, honestly, can't complain. Their interface is very easy to use. Their service is second to none. I've had to contact them a couple of times about certain things that I wanted to do, and they were brilliant. So you may be wondering why I do need a VPN at all. It's all about privacy. Do you really want big tech companies, governments and others knowing what's going on with your online activity? Even if you're having nothing to hide, it just feels downright creepy. I think you'll agree. And governments are getting more and more interested in what you're doing every day. And so, yeah, protecting your privacy is what VPN is all about. And how often do you run across websites that you want to get information from only to find that they're geo-blocked? This is becoming an increasing problem, but ExpressVPN solves that problem for you. Now, if you go to our special URL, you'll see quite a list of things this service can help you with, things you may never have thought of before. As I say, it's the one I use, secure, fast, and it just works. So protect yourself online today and find out more about how to get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Try expressvpn.com/space to learn more, and you'll find the link details in the show notes and on our website. Now, back to the show.
Okay, we checked all 4 systems and keying with a go.
Space Nuts.
Now, Fred, it's reached a point, I suppose, with space travel that a lot of what happens doesn't even make the news anymore. When we first started putting people into orbit, it was just front page around the world and captivated the hearts and minds of people everywhere. And then it sort of waned, and then it came back again with missions to Mars and so on and so forth, sending probes. And then the space shuttle program, which sort of kept people going, and then a couple of disasters that sort of piqued people's interests. And then things settled down, and space missions have sort of become fairly normal to the point where they're happening and we don't even know it, because they rarely make the news unless you pursue it yourself by following certain websites and blogs and so on. But there is a story that has made a lot of news at the moment, and that is the plan to do an all-female spacewalk, which sadly has been cancelled.
Probably only temporarily, I would guess, because I don't think it'll be long before we've got all-female spacewalks. So, of course, it's part of the routine of work on board the International Space Station. The people have to go outside from time to time to not kick the tires and check the wheels. It's more about changing equipment usually, and that involves spacewalks, which always involve 2 astronauts. I think. There are times perhaps when it's only 1, but usually it's 2. And there were plans for something quite impressive coming up. I think it was going to be early in April, I think possibly next week as we speak, for the first all-female spacewalk with 2 female astronauts, because at the moment there are 2 ladies up there on the International Space Station, Christina Koch and Anne McLean, who are both, qualified for spacewalking. So the idea was that there is an installation needed on the outside of the space station, and it's installing batteries. And I guess these are fairly solid lumps of technology rather than the kind of thing that you put in your camera or anything like that. The installation of those batteries was going to be the very first spacewalk mission with 2 females. But it's been canned.
Now, the question obviously is why, and I know the answer, and it's sort of I mean, no, one of them didn't get sick. It was nothing like that. It's something much more unfortunate or mundane or whatever you want to call it. It's just one of those quirks of fate, I suppose you'd call it.
I think it is a quirk of fate, but you have to choose your words carefully here, because it strikes me as being a very I can't even say it. It's a sort of feminine thing, in the sense that I know my partner, for example, has to be sure that she's wearing the right thing before she goes out. I know she's actually a lot less picky than some people that I've been involved with in the past.
Keep digging, Fred. Keep digging.
Yeah, keep digging, I know. But yeah, it's a wardrobe issue, because there's only one spacesuit the right size. And it's a medium size, and that's what's caused the issue. It turns out that both these astronauts need a medium-sized spacesuit. There are actually two medium-sized spacesuits on board the space station, but you need so much preparation. One of them is ready for space flight, one's not, and it needs so much preparation that the more rapid solution to the problem is to basically cancel, for now anyway, the two female spacewalk, and it comes about because let me just get this the right way round. That I think Anne McLean has trained with both medium and large sized spacesuits, but it turns out the medium one fits her better. And that's probably why the change has been made, because Christina Koch is definitely a medium. And so that's what has actually caused the issue. Two people the same size. Now, you might think, well, surely a spacesuit is not particularly specific in size. It's just a big kind of bag with air in it that has arms and legs that people get into. But apparently, it's all about what's called the hard upper torso, the shirt of the spacesuit, which is a pretty solid part of it, which really needs to fit specifically to the astronaut that's going to use it. And so rather than try and engage on getting the second medium-sized one ready, what has happened is that there's been a change in astronaut rather than a change in spacesuit. There is a comment that's come from somebody called Brandy Dean, who's a spokeswoman at the Johnson Space Center in Houston, saying, and this is something I guess you and I have talked about this kind of thing before, people's sizes change when they get into space.
Yes, that's right.
As soon as you get in microgravity, it brings about changes in the body. Do you remember that story? Was it last year? Somebody who grew about 4 inches or something?
Right. Yeah, it was actually probably a bit longer than that, year before last maybe. But yeah, he grew 4 inches, and he was a twin, wasn't he?
Yeah, it turned out to be a mistake, I think, in the end. Yeah. Anyway, that's the bottom line. So it's disappointing that we're not going to have the world's first, universe's first.
Instead, they're sending out one of the male astronauts, Nick Hague, and this is where the other problem came in, Fred. His sex change operation just wasn't done in time. They just couldn't finish, so he has to go out as a man.
Yeah, just keep digging, Andrew. That's
2 giant holes. Cover us up.
Big holes there.
Yeah, no, I'm sure they'll get around to it though, because it would be a great moment. And is it true? I have a vague memory that women are better equipped physiologically for space. Aren't they better suited to be astronauts than men?
I don't know the answer to that, but it would not surprise me at all.
I got a feeling that's the case. I think I read it somewhere. They just seem to be better suited. Boom, boom.
You probably read it in one of your science fiction books.
Except in this case, not better suited, which is unfortunate. Yeah. But we'll certainly tell you when it happens, because I think they'll get another crack at it in the not too distant future. This is Space Nuts. I'm Andrew Dunkley, and he's Fred Watson.
3, 2, 1.
Space Nuts.
Now, Fred, time to bump off a couple of questions. We're going to start with one that we actually got recently, but it sort of tickled our fancy, and we're going to tackle it now. This comes from Kev in Melbourne. G'day, Kev. Thanks for the question. We love this question. It basically goes something like this. I'm wondering if you can advise what would likely happen if an astronaut was to decide to hurl a tool as fast as they can at Earth while spacewalking. Obviously, they would go backwards themselves somewhat, but what would happen to the tool? With a high sideways velocity, the tool would not fall straight down, but would it pick up speed under gravity and without any air pressure for some time? Any chance it would hit the ground? Good question. Now, before you answer it, I was watching a science fiction animation recently, a program called, what's it called? Death, Love Plus Robots. And this was an episode called Helping Hand. And to give you the short story, an astronaut was out doing maintenance on a satellite. She got knocked off the satellite by something, space junk that hit the satellite and dislodged her. She lost all power to her suit and could not use the jetpack to get back to her ship. When she realised she wasn't going to be rescued in time, she tourniqueted her arm and took the glove off, exposing her lower arm to open space, and it froze. With the other arm, she threw the glove in one direction to propel her in the opposite direction. Unfortunately, she missed and had to sever her arm and do it again, but she got back on her ship. Now, that's
why didn't you just throw the knife?
Well, yeah, that's a good question. But that's what he's talking about. That action of throwing something in space, propelling you in the opposite direction to where you've thrown the object. In her case, her arm. In this case, it could be a spanner or who knows what. So yeah, what's the story, Fred?
Well, it's certainly true. If you threw something in space, it would propel you slightly backwards, but only by much. Well, unless it was something with almost the same weight as you, that would be a much lower velocity that you would impel yourself backwards with than whatever it is you're throwing. But it interested me too. Did this the way to? So the last part of Kev's question is any chance it would make it to ground, and the answer is no, because a glove is, if you could make it lose altitude enough that it would hit the Earth's atmosphere, it would burn up very quickly. So it would basically just burn up under the speed. But what interests me about it is what you would actually do, because you wouldn't throw it directly downwards. Because if you do that, the object you've thrown, let's say it's a tool, a spanner or something like that, if you throw it downwards, it's essentially still got the same horizontal velocity as you have.
Yes.
It's at a slightly lower altitude, but it's still moving at the same speed effectively. And what would happen is paradoxically, it would start overtaking you because it's lower, it's nearer to the Earth, and its orbital speed will be higher when it's nearer to the Earth. But that also means it's nearer to the Earth's atmosphere. I mean, we're talking about relatively small distances here. If you really wanted to get it back into the atmosphere as fast as you could, though, what you would do would be throw it backwards. So give it a velocity opposite to the one that you're being carried forwards with, and that velocity is nearly 8 kilometers per second. So anything you could throw doesn't really make much of an impact on that, but it would reduce it very slightly. So you throw the tool backwards, and that means it's now moving at a lower velocity, which puts it into a lower orbit. So it would actually eventually overtake you, even though you've thrown it backwards, because it would sink below the orbit that you're in, and a lower orbit means going faster. And that would almost certainly hit the atmosphere earlier. It's a bit like when you want to change the orbit of a spacecraft. For example, let's look at the opposite problem. If you are in an orbit around the Earth and you want to put your spacecraft into a higher orbit, you basically do a forward you burn off the rocket exhaust backwards, that propels you forwards, gives you an extra velocity. And what that does is it turns your orbit into an ellipse, an elongated circle, which at its highest point is actually moving slower than you were to start with. Even though you've given it more velocity, you're moving more slowly. It's a bit bizarre. You've put more energy into it, though, so it's a higher energy orbit. It's all a bit, uncanny is the way orbits work. But yeah, it's a very nice question. And I hope somebody will try it one of these days, throw something backwards out the International Space Station.
Would it be hard to do, given the velocity of travel? I mean, it's just hard to imagine throwing something against the flow, but there's nothing out there. So you wouldn't be feeling anything, would you? No,
that's right. So if you throw an object out of the, backwards from the motion of the International Space Station, it would actually look more or less the same whichever way you threw it, because it would just be propelled off into the distance. But it's what happens to it later as the orbital mechanics kick in that make it different.
Okay, but if whatever direction you did throw it, you would be propelled somewhat the opposite way.
Yeah, very slightly, that's right.
Okay, so no cutting off arms in space and throwing them at things, because that's never a good idea. And I'm sure a tourniquet wouldn't actually seal the breach in your suit, and you'd probably die anyway. That's my way of thinking. But, science fiction, you can do whatever you like.
That's why your series is called Death, Love and Robots. The clue is in the first word.
It's a bizarre series. They're animated films and they're all about 10 or 15 minutes long. That episode was called Helping Hand, just in case someone's wondering. It was really good.
Remind me not to watch it.
Some of them are bizarre. Now, let's move on. We've got a question from Hugh Simmons. Hugh's a bit of a regular, but he comes up with some interesting ideas, and he obviously listened to something we talked about recently in regard to black holes evaporating. And he said, I'm curious about this one. Or more curious about this one, because I think he asked us another question. When a black hole evaporates, does its mass lessen to the point where it turns into something like a neutron star, or does it just eventually evaporate to nothing? I cannot imagine a black hole becoming nothing.
Yeah.
Because it's nothing already.
Well, it's something. It's got mass. Some of them have got, 4 billion times the mass.
You can't see it.
You can see what's going on around it.
Yes,
yeah.
You can.
So the reason why it's got, it's a point of black holes defined as a point of infinite density, as we've mentioned before, and the reason why it's infinite is because even though it's got mass, it's got no volume, and the density of an object is mass over volume, and so if you're dividing a mass which might be 4 billion times the mass of the sun by a volume which is 0, it's always going to turn out to be infinity. It doesn't matter what you put on the top of the equation. So that's right. So it's definitely not nothing. However, what's interesting about this question is it's one I've never thought about before, I have to say, but my guess is that the answer is it evaporates to nothing because. Let's look at the process of evaporation. This is
sounding very Monty Python. Nothing can come from nothing.
All of black hole theory is straight out of Monty Python.
I'm sure it is.
The two ways about it. It's the process is Hawking radiation that makes it evaporate, and that's a quantum effect. It's when you get these virtual particles being formed, virtual particle pairs being formed. In space, out of nothingness. This is where it gets even more Monty Python. If one's formed on one side of the event horizon, the other's on the other, then one's lost into space and the other stays in the black hole, and it basically evaporates. Over billions of years. What did we say last time we spoke about this? That if you had a black hole, the mass of the sun, one solar mass, it will take 10 to the power 64 years to evaporate. It's a very long job. And of course, the universe is only, 13.8 times 10 to the 9 years old. So it's a lot longer than the age of the universe. However, my guess is that it would fizzle away to nothing and not to an intermediate mass object, because a neutron star is the result of a star collapsing at the end of its life when the nuclear processes give out because it's run out of fuel, so that there isn't the radiation pressure to keep the thing inflated, a star collapses. And if it's above, we now know actually it's 2.2. Sorry, if it's less than 2.2 times the mass of the sun, but more than 1.4 times the mass of the sun, it will turn into a neutron star. What that means is that the matter of this object collapses and is only stopped from further collapse by the outward pressure of neutrons jostling against one another, which is why it's called a neutron star. That's an entity then that exists and does weird things. We get pulsars and all sorts of things like that from these objects. But its collapse has been stopped. With a black hole, that's not happened. A black hole has more than 2.2 times the mass of the sun. Neutron pressure won't stop the collapse. So it goes down to this singularity, a point of infinite density, and it can't then go back to becoming a neutron star. So as it evaporates, it will just lose its mass to space and eventually will just fizzle out altogether and there won't be anything there.
That's a bit sad.
It is. It's such a sad
When you think
story.
of something so cataclysmically powerful, you just wouldn't anticipate that it'll just fizzle into nothingness over a long period of time.
long time, that's right, yeah.
But, yeah, I suppose everything ends.
Everything comes to an end, even black holes, that's right. And even space nuts.
Oh, not yet.
No, today.
We're just about to do that. Yes.
Today. I'm only thinking about today, Andrew. Don't get any wild ideas about where I'm going. I'm not going anywhere.
Very good. And thank you, Hugh, for your question. It was a real good one to get the brain matter munching. And we do love your questions. Keep them coming, and we'll do our best to answer them all. We're trying to double up and do 2 a week, so just 1.5 questions sent to us a week, please, so that we can catch up slowly like a black hole would. And thank you, Fred, as always. It's a great pleasure and a lot of fun.
Good to talk to you, Andrew, and we'll speak next time.
We will. Fred Watson, astronomer at large. And from me, Andrew Dunkley, thanks again for listening, and keep those cards and letters rolling in. We'll catch you real soon.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Subscribe to the full podcast on iTunes and Stitcher or your favourite podcast distributor.
This has been another quality podcast production from Bytes.com.
With Kroger brand products from Baker's, you can make all your favorite things this holiday season. Because Kroger brand's proven quality products come at exceptionally low prices. And with a money-back quality guarantee, every dish is sure to be a favorite.
These are a few of my favorite things.
Whether you shop delivery, pickup, or in-store, Kroger brand has all your favorite things. Baker's, fresh for everyone.